All right, let's dive deeper into Docker and get our hands dirty, so to speak. So in part one, we talked a lot about what Docker is, right? It's to help us make it easy to run code in many places and many environments. We need just not the Python code that I write, but the Python runtime to run a Python program. If I've got a back-end web app, there's all these frameworks and libraries that gets installed. There's a lot of things that the full stack applications and programs need to run. Docker is sort of a lightweight virtual machine, and we use what's called a container as a standardized way, like a shipping container, to share application environments that can have my code, right? And so now let's talk a bit more about this. And so we are going to learn the workflow to create and run Docker containers. We will learn about the Docker file, the config file. We'll see how to use a Docker file to build a Docker image. And we'll see how to then use that Docker image to run a Docker container based on that image. We'll see how to copy files into a Docker image. And most of all, we'll see what this whole workflow looks like. So let's dive into this and start talking about these things, right? And so there's three big terms here that I've talked about. And one of them is the Docker file. And this is like a recipe, a text file, and almost all our text, the files that we work with when we're writing software are text files. So when I say file, I just mean text file, whether the file extension is .md. You don't even need a file extension. Like right now, I'm going to make a Docker file. And note that this file doesn't have a file extension, but it's still a text file that we can do stuff with. And we'll come back to that in just a minute. It is a configuration or config file, and it's like a recipe. It's like a page in a cookbook that's a recipe. We use the Docker file to create a Docker image. We use the recipe, a Docker file, to, let's call it like, construct our cake, which is not yet baked. And this is where the metaphor breaks down a little bit, but the Docker image is the result of building a recipe. It's also a bit like a blueprint because, most importantly, a Docker image does not do anything. Once I have used my recipe, and I like to think of, if you like if you like create a cake following the recipe, but it hasn't gone in the oven yet, the cake isn't baked. So I like to think of the Docker files, the recipe. I've like made the cake or the pie, but the pie is not baked yet, right? It's not done. And that's where the Docker container comes in. And this is where, to simply put it, a Docker container is what you get when you run an image, right? We have now baked the cake. The cake is done. Or we've used the blueprint to build a car, whichever metaphor you prefer. Um, it's a package snapshot that has everything needed to run my application. Um, or I apologize. I'm getting a little confused here, and I'm kind of jumping around between the different parts a bit too much. Um, that's really more about the Docker image. This is our runtime. We can start and stop Docker containers. Docker containers actually do stuff, right? It's sort of like an isolated process, as in like the operating system has, they call it processes. Like when you run a program, the operating system runs a process, and that's where our code runs. Um, in fact, on the command line, if you type in the PS command, it shows you all the different running processes, and we can see here some of them. There's some shell and other things, and in fact, I think it's I always forget the command. There we go. There's a whole bunch of things always running right in the background on our computer in the operating system. And it does that with the process. And a Docker container is sort of like that. So we we make our recipe, we use it to kind of build the cake, and then we bake the cake, right? And this is a very reliable process. And let's see what this looks like, and let's start building a Docker container. Cami, yes.
Okay, so your analogy is breaking my brain right now. So could we say that like the Docker file is the recipe, the image is like the bowl that the recipe's in, and then the Docker container is like the oven that's gonna bake it?
Yeah, I agree.
Because
That's
I'm
where,
like, the way you were saying it, I'm like, no, it doesn't, I can't.
yeah, let me think about that for a sec, because I agree that one's a little tricky. And it does get a little tricky. Um, it might be better to think of it as, and let's make this larger. That might be a better way to think about it. The
Okay, yeah,
Docker
that
file.
works. That
Yeah.
works.
Yeah, thank you for asking. Yeah, no, I realize the metaphors, it gets a little tricky. And the truth it is a little tricky because you can use an image and create multiple containers from it and have them be slightly configured in different ways. So the metaphor does break down a little bit, but I think this is good. The Docker file is going to be our recipe. We then gather up all the ingredients, but just like if I'm, making an omelet, the recipe might call for this, but I might need to make a replacement, or it might be a different kind of mushroom, or I might do something slightly different. And then I actually have to, like, once I actually cook the ingredients, I have the meal, and that's my Docker container. And again, it breaks down a little bit here because we can do stuff with Docker containers, like start them and stop them. But I think that's the closest we're going to get with this particular analogy. I'll think about if there's a different one that works better, actually, because you raise a good point. Um, and on that note, and that's the thing too with this stuff. A lot of the times, the writing of the code is the best way to learn a concept because it forces you to grapple with it and then kind of experiment. And I think that will help a little bit with this as well. So when we're writing our config file or our recipe, the Docker file always starts with a from statement. And I'll break down in just a moment what each of these commands are doing. And I want to emphasize this Docker file, it's just a text file. Um, there's no magic. Everything in the programming world, it's like the traffic rules of stop on red and stop signs and so on. It only works when everyone follows the rules. Like I could put something in this file and the file is still fine, but if I tried to run it, it would break. And this red squiggly we see is because the creators of VS Code have told VS Code the traffic rules. that if a file is named Docker file, it's supposed to look a certain way. So this from statement is telling Docker what Docker image we want to use. This is called a base image. And in fact, if I hover over it, you can see we have this nice autocomplete, and you can kind of see the syntax here. And in fact, if we, I think there we go. The Docker docs are also pretty great if you want to dig into them. The documentation is challenging to read. It is good to practice because it is a learned skill because it gets pretty deep. So I think it's always good to look at them a little bit. Um, so let's look up though in Docker Hub uh, this Docker image name Alpine. And let's see what this is real quick. And we see it says a minimal Docker image based on Alpine Linux with a complete package index, blah, 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 blah. So the key thing here is Alpine Linux, right? Linux is an operating system. It's open source. Because it's open source and anyone can work on it, there's many different varieties or flavors of Linux. Like Ubuntu is a really popular version of Linux that most people use. For those of you on Windows who install WSL, that's the version that'll be installed. Um, Mac OS X is a very distant cousin of Linux. So there's different flavors or distributions. Arch is another one. Red Hat is a big one in the enterprise world. And this one, Alpine, is like a really tiny, minimal version of the Linux operating system, really kind of meant for stuff like this. And so, whenever you're working with a config file or code and you run into something you don't see, it's always good to take just a couple minutes and Google it up. I don't need to go super deep into this. I just want to give this like a skim and kind of take a look. And they kind of point out here that this version of Linux only takes up 36.8 megabytes. This other version of the Linux operating system, Ubuntu, takes up 145 megabytes, right? Like so 4 times that. Um, so I'm telling the Docker file that we're going to, inside this image we're building, we're going to use this version of Linux. So it's going to install that. And then I'm telling Docker inside that version of Linux, when I run the container, and let's see here, is this how I add a comment? Command to run when we start the container. I think that's how we add a comment here. Base image to use when we create image, when we build image, right? So we are going to build an image that has this version of Linux in it. When I then create the recipe, this command is going to run inside there and inside that version of Linux. And let me break down this command. And I'm going to break it down by showing you guys what it would look like without even worrying about Docker, because I know there's a couple new things here. On the command line, as you all have noticed, often called the shell or the terminal, they're slightly different things, which we can discuss later, but this shell program that's running right here in this VS Code terminal, I can use a keyboard shortcut. I can go to terminal up here to open it up. I can create multiple instances of it if I want. Excuse me. I can also, what's quite useful, if you right click on a file in the VS Code File Explorer and go to open an integrated terminal, it will open up a shell session in the terminal in that spot. So if you sort of lose your orientation. And this shell session I'm running here in the terminal, as you can see, there's all these different commands that kind of come built in. And it's sort of like its own little programming language. And every programming language needs a print statement. And because Linux and Unix, its forefather that we get the shell and the command line from, was created back in like 1970, there's a lot of like old school insider programmer jokes, or people didn't think about it a lot. And because computers were so slow, it took forever to type. And so that's why all these commands are short and terse and arcane. And so echo is that version of print. and it would help if I got my quotes right. And so here we see that this is the shell scripting language. This is its print statement. And it's printing this to the terminal or the standard output. So basically, and in fact, let me get rid of the comma just in case it causes problems. And I don't think the exclamation point causes problems, but let's, yep. Actually, I think the exclamation point does cause a problem because this is old and arcane. So now that one is solved. And so when I run this container inside the container, it's going to do exactly that, right? It's going to print this inside the shell in the container. But we haven't done any of this yet, right? And now that I have my config file, my recipe, let's build the image. And I use the Docker build command. Remember, I have Docker desktop running on my Mac. With WSL it'll be a little different, but you make sure you have this up and going. And we say build, and note how on the command line, it's sometimes you might just type one command by itself, right? And I'm listing all the directories and files in this current directory. Sometimes I might give arguments to this command, like if I want to list everything in a directory up, or sometimes you'll see an argument given to that command with a dash, and those are called flags. Maybe if I do it like that, there we go. And so I'm giving this Docker command line program that we've installed an argument, build. We're going to build an image, and we need to give it this -t flag, which lets us give it a name or a tag. And then that tag is what we're going to call it. And it's going to be hello Docker. And this dot, the dot on the command line means the current directory I'm in. Right? So if I look in the current directory, this Docker file is there. I have to run this build command in the same directory that the Docker file is in, because the dot is going to tell Docker to look for a file named Docker file in this directory. And we see these long messages. And you all will also soon learn that there's a lot of command line stuff that you kind of skim over. Just because you see a whole bunch of stuff doesn't always mean there's a problem. You usually want to look at the bottom or the very top of a long bunch of output to see if there's an issue. This is just saying that it has gone ahead and built this image. And in fact, if I go over to Docker desktop and I go to images, we see there's a whole bunch of images that I've been playing around with stuff here. But if I search for hello, we see this image that I just created, hello Docker, right? And it tells us the layers. In fact, we see that command, and it's kind of a nice visual way to show us some information about what we did. Another way to do that is on the command line. If I want to see a list of all the Docker images I've created, I can just say Docker images. And because I haven't been kind of cleaning up the Docker images, because we're always creating them for different lessons and stuff, you can see there's a whole bunch of images floating around here, right? For all of you, it will probably just be the one, which is this hello Docker right here that we've created. So now I have, right, we've made an image. And what we're going to do next is we're going to make our container, right? And our container is going to have two things. It's going to have the environment. And in this case, that really means Alpine Linux, right? That's really the only thing we've added here, and whatever is in it. And inside that environment, we are going to do things. We're going to have executions or commands, right? Things that the container is going to do. And in this case, it's that echo hello world message. So let me go ahead and clear my command line. And I've done all this talking. Let's actually create and run our container. And we see that it prints hello world, right? And this seems pretty simple, but if we step back a bit, right? If we zoom out a little, let's remember that this whole container is just one piece of the puzzle on my laptop, right? And in fact, and let's kind of put it maybe over here, right? And in fact, over here, I have my on my laptop, I have, my VS Code shell session or command line. And this is where we did all of that work, right? This is where I did Docker build. This is where, we then did Docker run. This is where the Docker file lives, and so on. And so, now here, we'll get rid of that. What's happened is actually, even though the output is really straightforward, when I ran Docker run, that created and started a container that's like its own little lightweight virtual machine. And it ran that command, hello world, and it sent that output outside of the container, right? And back into our shell session. So even though all we did is a simple hello world print statement, it happened in its own self-contained environment that is not where I am editing text files and running stuff on the command line and so on. So that's kind of a key point there that I want to emphasize. And I just want to pause and check in and see if folks have any questions about things so far. Okay, cool. So this is a good start, right? But we might want to do more. And I mean, among other things, we have a file system, right? And inside that file system on my computer, I have, well, there's the Docker file, and I might have some Python code or like a text file with some user data that I need to put inside my container. So how can I get a file from my operating system inside the container? And to do that, let's start by let's create a file, and the touch command will create a file with whatever name I tell it to. So we now have a file named message.txt, and let's open it up in our VS Code. And let's say hello from inside the container, and we'll save it. Right. And so now over here, I have message.txt. So we have to go back to our recipe, right? And we have to tell Docker what directory in the container to do stuff. And we have to tell Docker to copy the file from my file system to inside, I suppose I should say image here. I do use them a little bit interchangeably, inside the image, right? And so we're setting inside this container when it runs, we're telling Docker to go to this directory, which we'll call app, that already exists inside Alpine Linux. And we're going to say copy. And remember, the Docker file, right, and the message.txt file, they're both in the same directory. And so that's why I can say copy.message.txt like this. If, the message directory was in, maybe it's, maybe there's an information directory. If I had an information directory here, or if it was a directory level up, um, outside, like a level up from where I currently am in my directory path, I would have to use two dots to move there. But since it's in the same directory as the Docker file and I'm running the Docker build command into that same spot, all these, we call them paths, the file paths work right. And again, think about stop signs and traffic signs, right? It's not a universal, it's not like a property of nature like gravity that you can't turn right on red. People can break the rules. It's just not going to end well. And it's same with paths and stuff like this. There's nothing that's keeping me from screwing this up. It's that I'm making sure everything follows the conventions so everything is looking in the right spot for things. So we have this copy command, and we'll keep that. Um, well, actually, let's change this command. I'll kind of comment that one out, and we can maybe come back to it later. And let's have a command to print the message file. And on the command line, there's a command called cat that will print out a file. And by the way, I'm hitting the tab key to autocomplete like that, which I do recommend getting in the habit of, right? And so that's going to print that out, and that's exactly what we're going to do here. And note how these two brackets, they kind of look like an array in JavaScript or a list in Python, right? And that's pretty much what they are. And so Docker knows that this first argument is the command we want to run. And then these next items in our array or list are the arguments we're passing to that command. And again, this is sort of the borderline between writing a config file and writing code, right? We're not writing a Python program to, count from 10 to 20 or like print out a message or interact with the user, but it's a little more than just writing to a text file. So now that I've done this, if I run my Docker container, I'm going to hit the up arrow to kind of move through the history of all the commands that I did. Well, it still says hello world, right? Because the recipe has changed, right? I'm still getting the same meal I had from before. I have to build a new image with my new recipe. And in fact, not just the up arrow, but I can hit the Control R key, which will let me kind of type to search through all of the commands I wrote, can be really useful as well when you're getting used to the command line. And so again, we're going to say Docker build, and we're going to add a tag. And let's give this a different name so we can tell the images apart. And let's call it file-demo. And now that's built. And if I type Docker images to list all of the different Docker images, and I do apologize as there's a lot of these, but we see here these two images up here. And if I now do Docker run file demo, we see that printed, right? And again, the magic here is all this work is happening inside this container, this like different application environment that's, it's not quite a virtual machine. We haven't quite totally incepted, but it's in our operating system and then sending the output back. So I can take this Docker file. Well, really, what I can do is I can take this Docker image and I can share it with anyone. Um, and we'll see that in a little bit. But this Docker image file demo, if I put it up on Docker Hub, right? You could search for it, and we'll do something like this in a little bit. You could download it and you could run it, right? And so while this example of printing the file is a very simple example, you could imagine how, as with a complex program, this is actually really useful. And I just want to pause here and see what questions folks have or what people are curious about. How are we doing here on a scale of like 1 to 10? Or if you want to use like sunny and cloudy emojis to indicate your sort of like level of brain busting, go right ahead. David, I see that's a like a oh my God. Yeah. So let's call that like a 10, right? Who else is kind of feeling like at a 10 right now? Yeah. Pretty much everyone, right? My rule of thumb is if like one person asks me a question, like five other people are wondering it. So I'm pretty sure if a couple of people are saying 10, that's like everyone. And that's why I asked too. And that's okay. And please like let us know because sometimes I have to explain things better. And sometimes I can also say, you know what? That's okay. This is going to be a lot right now, but we're going to be seeing this over and over and over the next 15 weeks. And we really are. And just to put this in context, tomorrow we'll be looking at Git. We'll actually be writing Python code like Wednesday, Thursday, and Friday. Next week will be more Python, and there will be other concepts. But I realize this more abstract system stuff that also throws you into the deep end onto the command line. We're going to be using it, but not all the time. So first off, I don't want you guys to freak out that if you don't have 100% understanding of all this right now, it's going to be trouble. That's simply not true. Second of all, there's a lot of concepts getting thrown out here all at once. So it frankly, it would make sense that people are kind of feeling like at a 10. Um, is it maybe about like the command line and just all of the stuff that's going on, or about the concepts, or about like why are we doing this, or all of the above?
For me, it's like trying to just kind of remember all of the different commands and what they do and why.
Right, right. That's an excellent point. And I have good news for you here. Uh, Nobody remembers all the commands, including me. I've been doing this for over a decade. So some of these commands, I've been doing some of this stuff for years. I can promise you, when I'm learning something new, I don't remember it. And I can also promise you, this stuff is so complicated that if I'm not doing this or I am, working with Python or something else, I forget stuff. I get rusty. I always have to take like a couple hours to prepare if I'm, teaching Docker and I haven't done it in a while. So remembering the commands is not the goal. And more of this stuff will sink in than you think. And that's also why kind of what I've been walking through here is here in the written curriculum, right, for you to go back to refer to as a guide. I'm also going to be sharing all this code in our demo and notes repo, and also why, the videos are recorded for you guys to go over later, but also why to get hands-on. So don't worry too much about mastering everything. That's impossible. There's a term in programming, magic, and we'll talk about too much magic. And Docker is, frankly, a lot of magic. Um, and that's a book, but let's just say programming, too much magic. Right. And so magic in programming refers to heavy reliance on abstractions, frameworks, blah, 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 blah. Point being, everyone in their journey about learning about software goes through different phases where there's a lot of magic. When I was a computer science undergrad, there's this one line of code we were learning Java, and I still remember it: public static void main int. I didn't know what it did for like 2 years at least, but I just had to have it be the first line of every program that I wrote. So one of the skills you all will learn is what things it's important to really dig into and which parts it's okay to say this is magic right now and that's okay. And with Docker, frankly, right now it's fine for all of this to be magic. It's going to be when you do the assignments and you run this a couple times that things will start to click. So hopefully that helps a little bit. Maybe.
Yeah, but yeah.
Awesome.
Less
Totally.
panic, I guess.
Yeah. No, no, I really appreciate you saying that, Cami, and Erica, I saw you nodding as well. I mean, I know I mentioned it in the day one stuff, but the whole drinking from the fire hose thing is real. And I've been there. Trust me, I did not go through Code Platoon, but I remember as a junior software engineer joining a very like small startup, and I learned all this stuff, and then all of a sudden there was a ton of stuff coming at me at a huge pace. Um, you all are going to feel overwhelmed, and that's just going to be normal. Like 2 weeks from now, this stuff will feel more comfortable. So just kind of file that away. For lack of a better term, don't panic. Don't freak out. Tiffany and Elia, our TAs, and me are going to help you guys be learning this stuff, and you guys all will as well. Um, I've taught a lot of cohorts, and trust me, you all will be shocked how much you have learned 6 weeks from now. You will then be panicking over something else, but it won't be this. Um, so honestly, that's the good news, and really the most important thing you all can do is like be reaching out to me or the TAs to say, hey, I really want to go over some of this, and just working through the assignments and working together, and a little bit of trusting the process right now, which I'm always hesitant to say, but in this case is really true. Um, to kind of come back to the container stuff. So if we kind of look at this now, um, and actually let me scroll down a bit because it's actually a different image that I want. This is the image that I want, right? When we're talking about this Docker container that we can start and stop, it has its environment with Alpine Linux, right? It has the commands that it executes. And inside the running container, we've also told it a working directory that we've copied a file into. Um, and again, I just want to reiterate, like, have any of you seen those kung fu movies where it's like they're having the person do the training and it's like they have no idea what they're doing and the kung fu master is like, put your arm here and like move your leg like this. And it's like these sort of ridiculous training scenes. Does this ring a bell to anyone? In a lot of ways, learning to code is kind of like that. Like it's especially at the intensity and pace of a boot camp, there's going to be a lot of stuff that you all are doing in the early stages where it's not clear what's going on. And right now, the most important thing is just to ask questions and write code. And I can promise you, like any question you're wondering about is definitely being wondered about by five other people. And it and not freak out. And if you guys keep doing that, then like not this week and maybe not next week, but by week 3 or 4, by week 4 and 5, you'll settle into a groove. Um, and also again, like we're really here to help you guys. There's not going to be some test that, is absolutely grueling and, we don't we are not a weed out program. That's not our approach at all. So just coming back to containers, and we're getting towards the end here, and then we'll be able to get hands-on and do some other things. Um, so we've built all these containers, but they all stick around, right? And so there's different ways to work with containers and images. And here's just some more commands. And you guys will find too, um, like learning these things will help with other command line things. This PS command for processes is on the command line as well. I don't have any running Docker containers right now, but if I do Docker PS-A, and I kind of pull this up, There's like all these different containers from things that I made, and I never followed the advice in our curriculum, and I never cleaned it up. Um, and it's a little messy here, right? Because the command line is running out of room. But if we look, we see here's one container that was running that's now stopped, the file demo one. And we see the tag name and the command that it runs. And in fact, Docker comes up with these random names that it gives things in addition to tags. And we see here our other Docker container that we created a little while before to print Hello World. And just to visualize this again in the GUI, if I go here to containers, I can see all of these. Um, Now it's a good idea to clean these up. As you all have noticed, I haven't done this. Um, as you all have probably noticed as well, Docker kind of like comes up with all these quirky names for containers in addition to the ones that I've made. So we can delete some of these containers. Um, Let me go ahead and create an empty text file real quick. On the command line, if I have a file I want to delete, I use the remove command. And as long as I'm in the same directory as that file, I can do rm or remove to delete that file, and then it's gone. Right. So be a little careful with rm until you get more comfortable on the command line. I often will double check before running rm to make sure I'm doing what I should. And so with our Docker images or our Docker containers, excuse me, with all of these containers sitting around, we're going to remove some of these as well. And we're going to do Docker rm and that's just rm, right? Quirky, Holden. Um, let's go ahead and let's Docker rm, and we can even add a -f, which is sort of a force override to make sure it's really deleted. And we can delete a couple more of these. Um, I don't know how the Docker program comes up with these names, but it does. And now if I type Docker, list all the processes, whether they're running or stopped, list all the containers, excuse me, whether they're running or stopped, we see there's a whole lot less, right? So that's nice, but it also would be nice if maybe I could start and stop a container and then have it be deleted when I'm done. Um, and let's see if our file demo container still exists. And it's still there, right? Because we have the image. And so if I do Docker PSA, we see that this new container was created again. And I could do, Docker run file demo. I would run it again. And in fact, now we have two file demo containers off of that same image. I mean, though they do the same thing. So this can be kind of annoying. So if I do Docker run and I use a command line flag, sometimes they have one dash, sometimes they have two dashes. And again, don't worry about memorizing this command. That's what the curriculum is for. And by the way, all the assessment projects are open book, right? Because that's how real software engineering works. Like software engineers don't memorize this stuff. We get really good at Googling things and knowing how to find them. And I have to, in fact, I don't even remember the name of the thing, file demo. There we go. That will run it, and it also then deletes the container when it's done. And we have these from before, but that third one was not created. So we can do this with both containers and images. I have a whole bunch of Docker images that I probably should have been cleaning up, as you can see here, but let's just delete this file demo image. And so we do Docker rm and we add an I for image, and we just say file demo. And we see an error. And it says, hey, I can't delete this image because there's actually a container that, so, the container is not running, but it was stopped and it still exists that uses it. Right. So if we look at our running containers and we see there's these two containers that they use it, they're not running right now, but they're stopped. And because they might need that image or to do something with it, Docker doesn't let us get rid of them. Or doesn't let us get rid of the image. So let's delete both of those. And then this other one here with the crazy name that Docker comes up with. And I'm going to hit the up arrow again just to move a bit through my command history. This RMI to delete the image. And now we see that that image is successfully deleted, right? And we see just the sort of unique identifier called a hash of that image. So we've covered a lot of ground here, and we're almost at the finish line here. I realize that especially for day one, this is a lot of stuff. And again, this stuff with Docker, we're not going to be doing this 100% of the time. There will be other things that are more straightforward. I also realize a lot of what's happening here is I know folks tackled InstallFest, but we're going right into the deep end on the command line and the shell here, right? The good news is we're going to be using the command line and the shell every day, and you guys will be shocked how quickly you get used to it. And although working on the command line with Docker will be challenging, because the command line and the shell and using it this way are like the tool bench of the programmer, it will actually help really accelerate your coding and your software engineering skills. And that is sort of my prelude and my way of saying we're about to do something that will also kind of add to the feeling of overwhelm a bit, which is we are going to write a program. It is not a Python program or a JavaScript program. It is called a shell script. All these commands that we're running, this shell program that's running here in my VS Code terminal, it has its own little programming language. And so we are going to write like a utility helper program to do this stuff for us. So I'm going to create a file named run.sh, which is short for shell or shell script. And I'm going to open it up in VS Code. And just for my own sanity, I'm going to close out most of these other things. And again, in the curriculum, I have the exact code that I'm going to write here, and I'm pulling it up here just as a reference so we can see this. And I was talking about magic, and this first line is a lot of magic, and we don't have to worry about this line too much. In short, it tells the operating system that this file is a shell script that's meant to be run by our shell and do certain things. So I'm going to create some variables. And when we do shell scripting, I just create a variable really simply. The convention is to always have the variable be uppercase. And if I was doing this on the command line, I would do something like this. My variable equals hello. And if I wanted to print that, I couldn't do this because that print statement is printing that message. I have to tell it it's a variable. And with shell scripting in the command line, we do that with a $sign. Right? And that's what we call a shell environment variable. And this is not a Docker specific thing and actually super useful. And again, I realize there's a whole lot of stuff happening here, and that's okay. Right? So we've created some variables with some useful information. The Docker image name we're going to use, the Docker container name we're going to use. Let's print out a command. Let's print out a message that's useful for us that tells us what's going on. We're using that $sign, right? So it's going to print out that name. We're going to write the Docker build command we were just learning about. And we're telling it, hey, build a Docker container and have it use this image name as a tag, or build an image, excuse me, and have the image use this name. And now let's actually run our Docker container. And again, I'm printing out messages just to help me when I run this program, see what's going on. And print statements like this, whether it's in a shell script, Python, or JavaScript, help a lot with debugging. Because when I run this, if there's an error and something goes wrong, I can look at my code line by line. And if I don't see this printed out, I know the error's got to be somewhere up here, right? But if I see this line printed out, but I don't see this line printed out, well, then I know the program got this far to line 7, but it didn't get there to line 8. So it's really good to put lots of little print statements in your code as you write it. And you can always get rid of them later when you're done. And so now let's run the container that we create. We'll tell Docker, delete it when done. We'll give it a name. And we'll tell it what Docker image to use. And now that I've written this run.sh file, I can use the command bash to run it from the command line. There's a couple different ways to do it, to run this command. And if we look at this, we see building image, view build details, running container, hello from inside container. Let's see, I may have run this the wrong way. No, it does the same thing, right? So we see these messages from before about it, building a Docker image and so on and so forth. We see the things that get printed out. Oh, there we go. I'm so sorry. I got confused, guys. So speaking of confusion, trust me, your programming is about being confused and then unconfusing yourself. I was like, where did these print statements go? But they're hiding here at the very bottom, right? Let me kind of move this off to the side, just to clear a little room for us to look at stuff. And so if we look line by line, what happened here, I run this command. It creates these variables in the shell environment. The order things get printed here gets a little out of order for reasons that I don't want to go into at the moment, but we see running container, right? We see that printed out. We should see building image. There we go. There's building image printed out. So actually this makes sense. And again, I apologize. This stuff, it's easy to get confused. So I always just try to go slow because I get confused, but then I get unconfused. So we hit line 7. We see building image printed out. We see this variable name here printed out. We see all the Docker messages as it runs the Docker build command. We see the running container command here from line 10. We then run a container using the image that we created, and we see the message that it prints out. So this is a lot of stuff, right? And again, right now, that's okay. And we really built this up piece by piece. And a lot of this, frankly, it'll be probably like over a series of weeks that all the pieces of this start to make sense. But where we've ended up here, just to kind of review, how to write a Docker file, which is the recipe for a Docker image, uh, how to build a Docker image, right? All our ingredients, how to run a Docker container, the meal, and we've seen how to start and stop containers. We've seen how to list all Docker images or containers, how to delete. This is a lot of stuff, right? This is genuinely a lot. And we've seen how to write a shell script to automate our workflow so that I could have whatever program I want. I can run my shell script to build my Docker image, create it and run a container, run the output, and clean up. And in a lot of ways, this is sort of the end state because what this is sort of like real world engineering, right? This stuff is complex. It is complicated. It is hard to remember. And we're going to do a lot of this manually because that's how you learn it. But professionally, once you all land your first job, you'll be writing shell scripts and stuff like this all the time because I will forget what these things are. So my job is to make the computer do the work for me. And then that's what this does. Um, so this is a lot right now, but it's going to be really powerful and build a lot of great foundations for us to work on. Let me pause and see what questions folks have. And I apologize, Cami. I saw your hand is up, and I realize I may have missed that for a while, so I'm sorry about that.
Yeah, I just had a quick question. I think I just missed it, but where did that last line come from? The hello from inside the container?
Yeah, that's a great question. We've covered so much ground here. So our Docker file, the recipe that we made when we kind of updated it is we grab a file, a text file that's not in the Docker image, but here in my computer. And that message is hello from inside.
Okay, okay. Yeah, I
Yeah,
think I just missed
all
that.
good. There's a lot of moving parts here, right? And again, like we're kind of, you know what I mean? We're taking apart the engine, right? The engine has a lot of pieces. Um, and so inside the container, it runs this command to print out that text file.
Okay.
And yeah, great question. Great question. Thank you for asking. And I have no doubt like a couple other folks are wondering the same thing. What other questions do people have? What else might be good for us to look over with the code or play around with, or what's on people's minds? Okay, cool. Let me walk through the assignment and then we'll pause and we'll discuss the rest of the day. Um, and again, everything we've walked through is here in the written curriculum as well. So the assignments for today with Docker go over the same fundamentals, right? We're going to ask you to create some directories on the command line and just practice these fundamentals that we've seen. Create a Docker file using Alpine Linux, just like we did. Give it a command to echo hello or anything that you want. And that's it, right? And we've kind of walked you through a lot of these steps. And again, think about, the Kung Fu movie where you're practicing the moves, or, when you're learning to play a sport and you build it up piece by piece, right? So there's a lot of steps laid out here, and you're going to get practice and reps and sets. And at the end, you'll have a Docker file. You'll be able to run it and see output on the terminal. And you'll see that the container was deleted after you're done. And you can see that each task kind of builds on the last a bit more and more and more, right? And so these are going to be great to work on individually or in small groups or with the TAs, and we can do a demo at the end of the day. And realistically, you probably won't get through all of these today, and that's okay. I think the goal is make sure you accomplish task one, right? And if you get to task two, that's awesome. Um, three and four will be icing on the cake, but especially as we ran into the afternoon for this part of the lecture, I think the critical path is just task. All right, let me go ahead and stop here. And thank you all very much. And let me stop our